So when you're working with scientific notation, I think sometimes we get into trouble when we think move decimal left, move decimal right. I think the most important thing to remember, and the reason scientific notation is useful, is to represent really big or really small numbers in a more simplified way. So basically, if you can just remember that positive powers of 10 are big numbers, and negative powers of 10 are going to make small numbers. So the only other thing to remember is you're allowed to have one digit, one number between 1 and 9, 1, 2, 3, 4, 5, 6, 7, 8, or 9 in front of decimal. And everything else has to go after the decimal. So if we remember those two things, then we can approach some of these problems here. So 10 to the third power, that's a positive power, so I'm supposed to make a big number, right? So if this is in scientific notation now, and they ask me to write it in standard notation, I'm going to make a big number. So yes, I am going to move the decimal. And in order to make a big number, if I move it this way, I'm going to make a really small number. So I'm going to move it this way in order to make a big number. And I'm going to move it 3 times. So 1, 2, 3. And if there's any blanks, I'm going to fill it in with a 0. So in standard notation, this would be 5680 or 5680. In the negative power means I need to make a really small number. So I need to move my decimal 5 places, but I need to make a small number. So if I move this way, I'm going to make a big number. So I'm going to move it this way. 1, 2, 3, 4, 5. And any blanks need to get a 0. So you don't insert the number of zeros that match the number. You just insert any that you need based on how far you moved. So in standard form, this number would look like 0.0000. Come on, that's a mess. It would be 0.000683. Now, when I have standard form and I have to do scientific notation, I want to think, is this number big or small? 0.0007. Now these zeros in front, your calculator would show them to you. You don't necessarily need them. So I have 0.0007. That's a small number. Now remember, in order to be scientific notation, I need one number. 1, 2, 3, 4, 5, 6, 7, 8, or 9 in front of the decimal. So this would have to be a 7. That's the only number here. And the decimal would have to go after it. So I can have 7.0 or just plain old 7 times 10 to the, well, how far did I have to move my decimal in order to get it here? I had to move it 1, 2, 3, 4 places. Now, it's tempting to say, oh, I moved to the right, so I'm going to put 4. But I want you to think about, was this number big or small to start with? 0.0007 is very small, so that means it was to the negative 4th power. So 7 times 10 to the negative 4th power would be represented as 0.0007. All right, now 2090, that's a big number, bigger than 1 digit. So we need to put our decimal here after 1 digit. So 2.090 is the only place the decimal is allowed to go after 1 digit. Times 10 to the, well, we know it's going to be a positive number, but how far? If we can't see the decimal, it's over here at the end. So it moved 1, 2, 3 places to end up there. So 10 to the 3rd. Now when we're multiplying numbers in scientific notation, we're going to multiply our coefficients like we always would. So we need to do 6.2 times 4. So that would give us, let's see, 6.2 times 4. Oops. 6.2 times 4 will give us 24.8. So we've got 24.8 times 10 to the, now this is kind of like your rules of exponents. When you have two of the same base multiplying, do you remember what you do with the powers? You add them. So 6 and 4 make 10, so 10 to the 10th power. Now that would be finished, except remember the only place your decimal is allowed to go is after one digit, so this is too big. So we have to add power. If it was too small, we'd have to subtract power, but we have to add power because this number was too big. It needs to go there. So 2.48 is acceptable. Times 10 to the, well, when we add power, we have to think about how many we had to move it. Just one. So we're going to add 1 to that. So it'll be 10 to the 11th power for our final answer.